In a world of machines and technology, human beings often seem divorced from nature. But perhaps the natural world is not so separate from us. Scientists have found new evidence linking humans to the simplest of creatures. These discoveries confirm age-old beliefs in the unity of all life. This diminutive creature, Amphioxus, tells us volumes about our own evolution. Without eyes, ears, or jaws, this is a very simple organism. Yet it has some surprising things in common with us. Amphioxus have some body equipment oddly like our own. Amphioxus has a nerve cord which relays commands from the brain. It has gill slits, just as human embryos do. It has segmented muscles that allow it to move, but the real innovation was the notochord, a stiffening rod reinforcing its shape. This was the precursor of a backbone. We carry vestiges of a notochord, the discs in our spine. Our spines place us in a special group of chordates called vertebrates. The backbone is the crux of every vertebrate body. It is the central scaffolding of the skeleton. All vertebrates have common ground with Amphioxus. But how did we become so much bigger, so much more complex? The same genes direct development in Amphioxus and every other animal with a backbone.
Vertebrates really became big dominant animals by getting extra genes, because an Amphioxus-like organism has relatively few genes. It has the same number of genes as your typical worm, your typical ant, your typical fly. Whereas vertebrates have done something rather special. They've taken this basic number of genes and they have simply duplicated them. Not once, but twice. And then they've changed them just a little bit. You suddenly have 4 times as many genes linked together to make brand new structures.
The quadrupling of genes led to the big animals.
Once jaws evolved, then the animals could switch from eating microscopic plants to something like becoming a predator and eating other animals, and therefore the animals can increase their body size.
Long before big mammals, fish were the first animals with bony jaws. In a world of spineless creatures, they flourished and dominated. Fishes developed all kinds of skull and jaw structures. Flexible jaws mean a wide mouth. Fish could make a fast meal of larger, more nourishing prey. Jaws helped them to become the most gigantic creatures on the planet. The most feared jaws of all allowed sharks to chomp their way right to the top of the food chain. Skulls protected the soft brain as it became larger. Fish became the geniuses of their time. But evolution is not a straight march forward. Without the fourfold increase in genes, some chordates would follow another path, living lives radically different from our own. Tunicates, fixed to the rocks, still laboriously siphon the waters for food. They may lack backbones, but they are related to us. One of our strangest relatives is the salp. They are small, about the size of a human hand. But when they reproduce, they string together like a wandering strand of pearls. This diaphanous cloud is secreted by another of our obscure cousins, a larvacean. The porous walls of its home allow tiny food particles to flow into an inner chamber where this blue, wispy animal feeds. These simple animals have remained in the sea. Fish, with more genes, were ready to take the next step, literally. The next step would be monumental. But it would take more than flimsy fins to carry fish out of the water. Our first limbed ancestors walked a fine line between being a fish and being a new kind of animal. Our ancestors had arrived on land, and for the first time, our family album contained creatures that could crawl, walk, or run along the water's edge. Some of the first animals on land were like fish out of water. Modern monitor lizards show us how reptiles, sporting innovations like jaws and legs, flourished on land. Their stronger limbs made them into all-terrain vehicles. They could even reproduce on land by laying eggs, which were like nutrition-filled cradles for their developing young. Few obstacles could stop hungry reptiles. But another group of reptiles would diverge from the family tree and find a new way to move. These animals abandoned the ability to walk across the land and began to slither. A modern king cobra is still a worthy match for any adversary. While they don't have limbs, snakes have their own secret weapons. No other creature accomplishes what a snake can do with its mouth alone. Without the help of limbs, it still needs to catch, pin down, kill, and eat its prey. A king cobra's usual fare is other snakes, like this rat snake. The cobra's lethal venom quickly immobilizes its scaly victim. One bite is all it takes, and then the cobra just holds tight as the poison takes effect. Its teeth face backward, allowing the cobra to draw the victim directly down into its stomach. Skulls and jaws are among nature's most elaborate creations, and they tell a fantastic tale. But if sheer size is the measure of things, there is one group of animals that stands above all others. Dinosaurs were the largest animals ever to walk the earth. Like us, they shared the genetic legacy of little Amphioxus. They also shared the ravenous appetite of the reptiles. Some dinosaur groups got larger and larger over millions of years. "65 million years ago, an enormous asteroid crashed into our planet. The resulting cataclysm wiped out over half the animal species and nearly all of the large animals on Earth. Emerging from the shadow of the dinosaurs were small, furry creatures. They were the mammals, and they would inherit the Earth. The disappearance of the dinosaur predators meant opportunity for the mammals. They fanned out into a world ripe for the picking. And their bodies would soon adapt to take full advantage of the chance that lay before them. Today, mammals are the largest and most powerful animals on the planet. But that power comes at a price. Warm-blooded mammals like us have metabolisms that require constant fuel. Mammals replaced the dinosaurs as the Earth's most voracious consumers. The constant need to feed would shape our bodies and brains. Gradually, we became the most intelligent animals, adapting brilliantly to life on Earth. Our closest animal relatives still live in remote forests. We are more closely connected to one group of primates than to any other animals. They act like us, even look like us. We see in them the increase of intelligence, the dawn of a similar consciousness. They are the great apes. They have evolved into thinking, feeling creatures. They nurture their own kind. They pass along social skills. Like us, they learn. They mimic. And they remember. We have so much in common, but the differences are profound.
Toda la vida estaba en el mar, pero había muy poquita vida. Entonces era el mar.
Our large human brains allow us to speak to each other and write down what we have learned, passing on knowledge from generation to generation. Our intelligence separates us from the other animals on Earth. We alone seek life's meaning and ask the big questions. Where did we come from? How did we get here?